Exciting. Thank you so much for having us along. We're so excited to be here. And I know that you did talk with one of our colleagues earlier this summer. So please stop us if we're repeating something that they've already talked to you about. We're happy to, there's lots to talk about. So we're happy to join a new topic. But I'll start by introducing ourselves. My name's Lindsay Holiday Van Dam. I use she, her pronouns. I'm the one over here. You probably can't see with my mask on who's talking very well. But it's great to see all your faces. Thanks for having your cameras on. So my role is a science communication fellow aboard the Nautilus. And if you have more questions about that, I can chat. But first, I'd like to introduce Jess.
Hi, yeah. Hey, everyone. My name is Jess Sandoval, and I'm one of the ROV pilots here on the Nautilus. So it's a great crowd because you guys are really talking about ROVs, and I love ROVs. So yeah.
Perfect. So I know you talked to, I think, Kylie earlier this summer, and similar to what was happening then, we are aboard the Nautilus. And currently we're in transit, so you can see that there's not a lot of activity on the screens behind us. In fact, we're the only ones in the control van right now. But in just a few days, we're going to have lots of folks in here. The whole control van will be filled. Right now, we're aboard the Nautilus. If you look kind of on the top of the ship there, right next to the big spherical satellite, you can see a couple of shipping containers. And Jess and I are sitting inside that last shipping container. That's our control van. And again, starting around Friday, we will be actively deploying our ROVs as well as some of our other stuff. So right now, Jess, what is currently happening as we're transiting to our destination?
Yeah, so we're getting the vehicles ready for basically all of our dives. So next 3 weeks of dives, we're just getting everything tuned. We're tuning certain kind of types of hydraulic flows, if you will, to make sure that when we're diving really deep, that things are working at the right rates and things that we're expecting them.
Yeah.
So yeah, a lot of turning wrenches and just making sure everything is ready to go.
Yeah, I can vouch that the ROV team is never sitting around. They have lots going on. We are also, as we're moving, we're able to do some seafloor mapping at the same time, which is pretty cool. We're able to get some really pretty pictures of what's happening on the seafloor. And that's really important because when we send those ROVs down, we want to have a pretty good idea of where we're going. And can you tell us a little bit about where we're going, Jess?
Yeah, well, I mean that's a yeah, I drive I just drive these things. No, I'm kidding. We're gonna be working a lot of subsea ridges right now, so we're gonna be doing a lot of like coral collections, which will be really exciting for folks on the beach or back at home. Um, I mean that's some of my favorite work is doing some coral work. I mean you get to see thousands of year old creatures on there, so corals. I mean, um, yeah, so we'll be doing a lot of kind of climbing up some ridges and doing a lot of really nice surveys and transects. Um,
Yeah. And specifically, we are located right now over in the Papahanaumokuakea Marine National Monument. So you can see on the map here, Hawaii is the green islands over on the far right side of the map. We have actually transited into the boundaries of the monument, and this is a marine protected area that protects a really important historical and cultural area for Native Hawaiians. And these were the former islands that have now um, are mostly atolls, but then there are also series of submarine seamounts, like Jess was talking about, those underwater mountains that are pretty exciting and end up being these amazing ecosystem habitats for a wide variety of organisms. So specifically, I think you can see my cursor, hopefully. We are going to be looking at some seamounts that kind of are definitely not on this map because they are underwater and have not been really well mapped, but they're going to be kind of stemming off of this area of, of the Marine National Monument. And we're going to be mapping those, and then we are also going to be sending ROVs down on a number of dives to, like Jess said, take coral samples to see if these are brand new species that have never been recorded before, and rock samples. And those rock samples are going to help us do a couple of different things. We've just had a few science briefings on what those rocks are doing. What was your understanding of why we take rocks from the seafloor, Jess?
yeah, so there's a whole variety of reasons why people are interested in the rocks. Whether it's to age them, not age the rocks in order to age what's the features down there. You can also tell a lot about how that feature has been formed based on the crystallizations in the rock, etc. And also people are really interested in the associates that live on the rocks. So any types of small little creatures that may be living and growing on these rocks as well. So there's a lot of people that are very interested in these rock samples that we collect. So it's between the geologists, the biologists, and everyone in between, the chemists as well.
Yeah, yeah. A lot of information that you can get from rocks and soil. I'm showing one other picture that actually shows the seamounts better where we're going to be heading. We just kind of crested over this ridge right here on our ship, and we're heading straight for this southernmost seamount. I believe it's an unnamed seamount. And then we'll be taking samples heading all along this chain here. So you can follow along on Google Earth. This is what's available right now. These maps are based on satellite images, and so we're excited to get some much stronger sampling from our multi-beam sonar maps as well. I know this is a ROV club, so you might be more interested in our ROVs. Although I don't want to bore you if you heard all about Hercules and Argus last time. They are kind of the stars of our show. All right, we'll give a brief overview. Jess, tell us a little bit about Hercules and Argus.
Sure, yeah, sure thing. ROV crowd, so ROV talk. There you go. Yeah, so we have Hercules and Argus. Argus is basically a two-body system, so two vehicles in the water in tandem at all times. Um, and so Argus is kind of higher up in the water column. There's a stiff cable between the ship and Argus, so you don't really dissociate the ship movements from Argus. And then the beautiful thing is that with a tandem or a two-body ROV system, is that we have another ROV, which is Hercules, kind of this bright yellow vehicle that you see in this picture here. And there's this soft cable between it. So if you can see this tether, we call it, which is basically a yellow cable, and that's really flexible. And that allows us to do a few things. So we can disassociate the movement of the ship from the actual movements of Hercules. So we can fly around, take some samples, and also not worry about, what the ship's doing up top, or it's, we're in a swell or whatnot. We can kind of disassociate those movements. But really the big star here is all the sampling and collections that we can do with Hercules. So there's two manipulators on board Hercules. You can see them in the front. One's a bit more dexterous, we would say, than the other. We also have 6 thrusters on board, so that allows us a lot of flexibility of going and turning in whichever way you want, especially when you're working on ridges and seamounts. Oh, this is a lovely exploded view. I'm just seeing some of this for the first time myself, or some of these really nice animations that are new now. But it's a really intricate system, though, full of, a variety of hydraulics, electronics, and it's really a mixture of a lot, if you will. And yeah, so, but the main gist here is that we have a much more versatile and what's the right word, but almost like an elegant swimmer, if you will, out of Hercules. And then Argus is more kind of holding down our eyes in the skies is what we usually say. We have sonars on it. We have this large HD camera in the front. We have a variety of little cameras as well. So we get a lot of spatial awareness from both vehicles and kind of stitching these together in our mind as to where we are spatially and how we can best, execute a mission.
Yeah, that's such a beautiful description. Thank you. As only an ROV pilot can give it. But so there's a little bit of an overview kind of how we'll be operating. And again, we should be on our site around Friday, or maybe even early or late tomorrow night, and then we'll be doing some of our sonar mapping on the site, and then hopefully getting those ROVs wet sometime on Fridays.
Yes, that's the hope. We'll be doing some mapping beforehand, so we'll be on site and mapping for I think almost 24 hours, yeah, and then starting our dives Friday. But these high resolution maps really allow us to get a good understanding what's on the seafloor before we actually put the vehicles on those spots, and it allows us some good ground truthing beforehand.
Yeah. Well, we could go on and on. I'd love to open it up to y'all's questions, so feel free to unmute and ask your question, or you can also, I can see the chat here if you feel more comfortable throwing your questions in the chat.
River,
and while you
go
get
ahead.
started, go ahead.
So you have a sonar of the whole entire of the surface to the bottom of the ocean, correct? Well, I'm sorry. How far does your sonar go down?
Oh, so are you talking about the
can it
multi-beam? Yeah, so we have a variety of different types of sonars on board. So the multi-beam that we're working on right now we're serving about 4,700 meters of water, and it's still getting a pretty good resolution. I'm not sure the overall depth rating on the multi-beam on the ship. But yeah, at least we can see probably at least 5 kilometers. And then the sonars on the vehicles are much, much shorter range. And so we have a slew of different sonars as well, but I would say around, 60 meters is probably you can get some good resolution there. And it really helps us for kind of forward seeing, looking for cliffs, stuff like that. If you go towards 100, you're gonna get a lot more noise. Closer in, you have better resolution on your sonars. But
So
yeah, so we
you're
use a
saying,
variety of different sonars.
so you're saying about 3 miles down?
Yeah, so yeah, when we're diving down. I'm not actually sure the good conversion to miles. This is pretty silly, but as I don't know the conversion. But yeah, so around 3 kilometers or so is usually our depth of the dive. Yeah.
Yeah, about 4,000 meters is the maximum for Hercules. So we're typically in a comfort zone a little bit shallower than that. It's about 3 kilometers.
Okay.
With about
Maria,
1.5 miles.
before you fly away, I see your hands going. Go ahead. And then Emily, I'll get you next.
How far are you from land? Like how many miles is she from land?
Yeah, we are currently about 90 miles from the closest land, and the closest land is what's called a shoal or an atoll. It is not even a full island. It's a very, very, very shallow, very old ancient island. So there is some sandbar there, but not much else. So we are quite a ways out, which is why it's taking us multiple days to transit to our dive site.
Emily?
So, how deep can Argos or Hercules go?
Yeah, so we have different depth ratings. Actually, Argus can go a little bit deeper, but about 4,000 meters generally for Hercules. And then Argus, I think, is now a deeper depth rating, but I don't want to misquote. So we'll just go with in tandem, both of them together, 4,000 meters.
Yeah, since we wouldn't ever send Argus, I don't think, deeper than Hercules.
Yeah, the only time is when we remove Argus physically from Hercules and we do an Argus only dive. But those are primarily, I mean, those only allow you limited capabilities, if you will. Yeah.
Okay, thank you.
Yeah, thanks for the question.
So what's one of the hardest things to do about driving the ROV underwater? Or what are some of the difficulties?
Yeah. Oh, that's a great question. Well, I guess a lot of it comes down to spatial awareness. So kind of stitching together in your mind where you're at spatially, where you're at on the map with relation to a lot of other features. So always kind of keeping aware is it's not difficult, but it's definitely the thing that you have to pay most attention to. But also too, even if the most difficult parts are actually kind of the human added elements as well. Last year we were working in a heavily fished area, and so there's a lot of fishing gear in the water, and so that's a lot of uncertainty, right? We know about the seafloor, geological features. These are all static in a way. There's currents and all, but we know how to counter those. But as soon as you have really unknown elements like fishing gear, ghost gear that are on the seafloor, I think that's one of the more challenging aspects for sure. You don't want that in your thrusters. Obviously, you don't want to get some, you don't want to anchor yourself to the seafloor in any way.
So you've also you've driven you've driven this. What has been the, I guess, best thing that you found, or what you were interested in, or what was the most interesting thing that you've done so far with the Nautilus?
Yeah, that's a hard question. That is probably the hardest question because everything is fantastic. So I started in 2015, and my first time out here, we were doing some work on hydrothermal vents down in the Galapagos. There's a bunch of these crazy squidworms that these flamboyant squidworms. I mean, you see all these like crazy creatures. That was kind of my first introduction to the Nautilus and to subsea work, piloting. And then from there, probably some of the most interesting stuff is like the whale falls, which is really fantastic. You get crazy incredible life off of that, doing photo mosaics. Working on the USS Independence was another staggering one. That was basically this scullied ship. And then also, yeah, just seeing this variety of life down there. You get these tube worms here when we work on hydrothermal vents. I mean, I think vent work is some of my favorite stuff. You can see one of these black smokers here. Yeah, so there's so many, it's such a nuanced answer because there's so many incredible things that we see on the seafloor.
Okay.
There's always an area of expertise to learn about. I think most of my experience on the Nautilus previous to this cruise has been around archaeology and biology and a little bit of the methane seep geology. But this time it's very much it's revolving around the microbiome of the rocks and the geo-aging of rock formations and the continental crust movement. So there's just if you have an interest, there's potentially something to look at and study and become an expert in underwater and around our oceans.
Before Maria's sister falls down because she's a little bit younger, what do you got for us?
Two things. One, her name is Marina.
Marina, sorry. Marina,
And
what do you
two,
got for us?
she's asking how big is Hercules?
Hercules is pretty big. I don't know if we have a good, let's see here. Let's do a good.
Do you want to do a live shot of Hercules?
Oh, that's true, yeah. Now you can see it. Yeah, so that's Hercules. You can see that's Jake there. Jake's pretty tall. So yeah, Hercules is probably about the size of, a little bit taller than the size of a car, I'd say. Yeah, it's a pretty big, and then Argus is also pretty long and 5,000 pounds heavy. So Hercules is also 5,000 pounds in air, and so they're quite large vehicles. That's a great. I love this shot actually.
I
That's cool.
know. We tell people you never know when you're on camera, so you got to be ready.
Yeah, exactly. But yeah, so Hercules, as you can see, it's pretty massive. The manipulators we were talking about before, these large robotic arms. You can see that's the guy that's standing there. He's actually putting on some sample jars. But that manipulator is as tall as him when it's folded up. So when it's unfolded, it's about twice the length of a human, if you will.
Wow. Very
So.
cool. And I know you mentioned this right at the start, Jess, like some of the things that your team is doing right now. But what are we prepping the ROV for a dive right now, or are we just testing the mechanisms, or what's going on?
Yeah, so right now you can see the fella standing there in the middle, kind of putting something up. He's putting up these large sample jars, so these are slurp jars. And so what that is, Steve is one of our science leads and science manager rather. And yeah, so he's installing these slurp jars, so these like rotating chambers, and we have a variety of chambers that rotate in a circle. We take a slurp sample, like a giant vacuum hose, and then it slurps them up into these jars that he's installing now. And then it looks like someone's installing a USBL beacon, which is basically telling, you can see like these random hands coming from the backside of the vehicle. That's what I mean. The USBL beacon is basically, gives us the spatial localization. So we know where the vehicles are on the seafloor.
Very cool. I think one of the most amazing things about being on this voyage and in general part of ocean exploration just is the amount of teamwork that it takes. And you can see this here, like all hands on. We've got engineers and scientists and ROV pilots and science communicators. We have data engineers, we have video engineers, we have the cooks, we have the seamen. I mean, we have it takes a lot of different talents and different people and lots of communication. So if
How
you're
many
interested in
crew?
ocean research, definitely work on people communication and people skills.
How many crew do you have on the ship right now?
Right now, probably we have less than capacity. Our capacity is generally on like 41 or 42, including the crew.
Yeah, I think we're right at 35. We have a kind of minimal crew, and then our science staff is right about 26 folks
Okay.
right now.
Of the 35, yeah.
Yeah.
And what are your backgrounds? How did you get on? How did you start doing this?
I'll start first because mine's a little different, but my background is in marine science education, and I've worked as a scientific diver and educator, and this is now my second cruise aboard the Nautilus.
Cool. Yeah, I came out here, I started out here actually as an intern with the ROV intern. I had no experience with ROVs back then, and that was 7 years ago or so, 7 or 8 years ago, and loved it, kept coming back out. I guess educationally, my background is I have my bachelor's in biological engineering, so instrumentation, at that point, building little microscopes and stuff. And I loved doing robotics ever since I was a kid, so I was also on the first robotics teams back in high school, And then I have my master's in mechanical engineering and robotics, and then my PhD in material science and engineering. Yeah, but I mean, you don't need, everyone finds their way out to the ship in different ways. You don't need a PhD or a master's to drive an ROV. But yeah, so everyone finds their own way out. Some folks come in from the Navy, some folks come in from school. So it really, really depends. But my first true introduction was actually just as an intern. I had no experience, but I was super excited and I just kept coming back out. So
That's so cool. Have you driven ROVs for any other ships or any other ROVs?
yeah. Oh, just primarily for like small little oil and gas contracts and stuff like that. But not as cool as this stuff. This stuff is very cool.
Hey, River
Well, we
and
probably have
Emily,
time for a
since you've
couple
been
more questions.
asking all types of questions on the chat, I want you to focus. Do you either of you have any or questions? So let's keep the chatter down on the chat unless you have a real question. River did say you're sorry, correct? Yes, shake your head. Thank you. Okay, enough about that. The gears aren't. We'll go from there. Who else have some questions for these, scientists that we have on tonight? Go ahead, River.
So I wonder if that thing weighed more than 2 tons. I guess it weighs 2 tons. Sorry, that's a bad estimate. I guess if it weighed 10 tons, so 20,000 pounds, do you think it would act any differently? Do you think it would fall in the water any faster?
Yeah, so
Or do you think it's
it's a good question. Yeah, so the interesting thing here is knowing how much it weighs in air and how much it weighs in water. So like I said before, Hercules weighs 5,000 pounds, but that's in air, and underwater it floats, right? And it floats up. And the reason why it does that is it has syntactic foam, and so really so that's kind of the curious distinction then. So Argus, though, is 5,000 pounds heavy in water. That means that we have a bunch of lead on it and it sinks. Yeah, so that's kind of the answer. It depends on maybe your buoyancy, depends on your amount of syntactic foam. You can make these ROVs larger and larger and heavier, but if you have enough syntactic foam to balance it out, then you're gonna float still. It's kind of a
Not
trippy.
just weight, is it? I mean, this ship that we're on weighs several tons, and we are not sinking.
And many
Yeah,
of you are sorry, ladies. Many of
Oh,
you
no,
are
no, please go ahead.
divers. Many of you are divers, so you know a little bit about buoyancy already. Okay. So a couple of questions we have. Jacob and Claire asked, how does the ROV control its buoyancy?
Yeah, so okay. Yeah, so the Hercules has these syntactic foam packs, so that's really allowing some positive buoyancy. But we don't have like a fine-tuning active control, if you will, so buoyancy is really kind of like a function of weight, right? So the amount of weight we put on it before. So we have these, we call them lead, or they're little bullets, we call them, they're little lead bullets. And we put those on, and we do some back calculations beforehand, so we know, how is this thing going to float, how positive or how light are we going to be underwater. Given that we know how much the syntactic foam is going to kind of pull us up in the water, and we have all these instruments that we're adding on, so it's added weight, we can kind of balance it by doing this calculation beforehand. But underwater, so we know that we always want to be slightly positive underwater for Hercules, and Argus is always really, really heavy and negative, right? So we have Hercules always kind of slightly floating, slightly positive. And then with our thrusters, we can now control and fine tune, how much thrust do we need to push ourselves to the ground or push ourselves off the ground. And so if we're trying to get ourselves off the seafloor rather, if we're too heavy, we've taken on too many rock samples, then we have these steel plates and then we'll toss off a steel plate. So if you guys ever watch the footage and we have a little brick, we toss it off, that's why. And those have these little, not hemp fiber, but little fibrous plant-based fiber in order for us to kind of manipulate that with the handle, and then that will all kind of decompose naturally without any added plastic. So it's kind of a really nuanced answer perhaps because a lot goes into it, these back calculations of how buoyant we are, and then also kind of fine-tuning with these added weights, and then also tossing off some extra weights. And overall, though, it really depends on how we're flying and how much thrust we're putting while we're flying. So hopefully that answers your question. It's a long, big circle, if you will.
Yeah, so many pieces, and hopefully y'all in your club are kind of exploring some of these items of buoyancy and thrust and all of that. I do see one last question I think we'll take, and then I'll leave you with an image to do your own exploration beyond this time. But so one of the questions is how long can they be underwater and how long are our dives? And our shifts are 4 hours because as humans, we need to get food, we need to sleep, we need to use the restroom. But the ROVs don't need that, which is pretty amazing. And it's one of the reasons we can leave them in 24, 48, typically no longer than 72 hours. And that 72-hour mark is really because at some point, even though we are taking shifts, we around the clock will have a team for 4 hours, and then we have an 8-hour break. But at some point, that can be strenuous on us. And so at 72 hours, we'll usually call the dive and hope that we've met our objectives up to that point and recover the ROVs for maintenance and for all the samples. And at some point, usually our sample bins are also full, so we have to come back to the surface. So we do encourage you to follow along. Again, we're hoping to be diving starting this Friday. So follow us on nautiluslive.org. When the light is green, currently, if you go there, you'll see a little spot where you can ask questions, and the light is red right now because no one's in the control van to answer questions. But when we're diving, myself or some of my colleagues will be sitting there happy to answer your questions. And we do encourage you to follow along. You'll get to hear Jess's voice. Jess, what's your shift? What's your watch?
I'm 8 to 12 Hawaiian time.
All right. So I'm also on the 8 to 12 watch. So you might get to hear our voices, but we have teams around the clock when those ROVs are diving, so don't miss out. And thank you all so much for today.
Are you guys going to get to see the lunar eclipse from the ocean? That would be awesome.
Yeah, so that's on the agenda. Rather, our expedition leader has been talking about that, so we're pretty excited about it.
Yeah, weather looks good for us. So, all right, please ask your questions online. Keep studying ROVs and science, and mahalo, aloha, everyone.